Okay, this video is drawing angles in standard position. So, well, the thing is that there's an issue of just how do you even define an angle. An angle could be defined as the union of two rays having a common point. And then the question is, well, what is a ray? A ray consists of one point on a line and all points extending in one direction from that point. Oh, well, I guess I'll write it down. A ray consists of one point and a line consisting of all points extending in one direction from that point. And so then if you look at an angle is the union of two rays having a common point. And this point right here is called the vertex. All right. Of the angle. The two rays are called sides. I mean, it's something that you can just visualize, right? All right. We use Greek letters to describe angles. Not all the time. And the letters we use would be this guy here, which is theta. These are lowercase for the most part. Phi, well, actually, that one, I don't know, maybe it isn't lowercase. Okay. Phi, which is what I'm drawing here. Alpha. And then beta. So these two are at lowercase, and gamma. Okay, so these are all just starting things. And when, all right, so the convention often, but not always, is to write one of the sides horizontally and not call that the initial side, and the other side is, and so when you draw this ray so that your first side, so that it opens at a point to the right, and then, just like the positive x-axis, actually in the same direction, that'll come into play. And then your other angle is above, or your other side's above here, and this is the terminal side. That's the convention. So in applications, the angle could be, in a different turned around in a different way. But when we're looking at these, it's sort of convenient just to stick with that convention when we're studying those. Okay, so the measure of an angle is the amount of rotation from the initial side to the terminal side. So that's the measure of an angle. 1 degree is 1 over 360 of a circular rotation. So a complete rotation contains 360 degrees. And then you write that 360 with this little circle above it. So I think I might have used the expression standard position before, but maybe that's not correct until I bring in the XY plane. So with the XY plane, what we do is we draw an angle, and we draw it such that its initial side lies along the x-axis, and then the terminal side is, well, somewhere else. So let's write the terminal side. So this is standard position. And then okay, a positive angle measures the angle in a counter clockwise rotation from the initial side to the terminal side. So you're measuring like this, and for whatever reason, that's the way we do that. So there's a bunch of reasons that aren't really all that clear right now, but it actually sort of has to do with just like how when you have a screwdriver, which way you turn the screwdriver. So there's something to that when you look at these angles. And what they consider a positive rotation. So this is a positive angle. And so you could have your angle looking like this. where you go this way. So this would be a negative angle. And okay, so let's just look at this one. So see what you're starting off with. Here's the initial side. And if you go around in a clockwise rotation, then you're going to get a positive number. Going this way, you get a negative number. I'm going to just go ahead and say that that looks like around negative 45 degrees. While this one, if you take 360 and minus 45, that's 315 degrees. So, I mean, the angle is still 45 degrees. So there's still this angle between the two is still 45 degrees. But when you do this rotation, we write negative 45. And there's a little subtle difference between if you just have a angle floating around on a plane or just anywhere on the plane, you'd say, oh, that's 45. I mean, roughly, actually. It's not really the best way I drew that. Roughly 45, I just said. Okay. So, but if you're looking at this position, you could put this is negative 45 degrees. And then, okay. So what we're doing is, first of all, this red part looks like an angle that we're used to. But see, what I'm also allowing under this setup, or this explanation when I put it in standard position, is I'm allowing, starting at the terminal side, to go all the way around here to the at the initial side, then I go all the way around to the terminal side. So I'm allowing myself an angle that's doesn't really look like an angle that's more than 180 degrees. I mean, in say an introductory geometry class, if I give you these two rays, you say, okay, here's the angle right here. You wouldn't go all the way around, but under this model here, this way we're it's not really a model. This construction here, we put this at the XY plane, and we have initial side as in terminal side, and we're allowing ourselves to have an angle that's more than 180 degrees. Like over here, half of 360 is 180. And so you're allowed to keep going under the way we're constructing angles in standard positions. So then we have angles called quadrantal angles. If the angle is drawn in standard position and the terminal side lies on either the X or Y axis, then the angle is called quadrantal. It's called a quadrantal angle. So it's sort of funny sounding name, but anyway, okay. So actually, let me just do this one right here, where I have, here's the terminal side, and then I'm going along the x-axis. All right, so keep in mind that all the way around, one time around is 360 degrees. And if you go 1/4 of the way around, we get 90 degrees. And which is a right angle. So these numbers are, maybe familiar. so 90-degree angles. But you, like I was showing before, let me just look at this terminal side. So if you have, let me just use this pen as the terminal side now. If I keep going around here, it sort of makes sense from our ideas of beginning geometry to have an angle that gets all the way up to around 180 degrees. But in this standard position, on the XY plane, we're allowing this angle to be 180 degrees. So we're going as shown in a counterclockwise way. And that's just the way it goes. It's a really big breakthrough that you could do this by putting this on the XY plane. So here, see, you're going to get 180. So 1/4 of the way is 90. 90 times 2 is 180. 90 times 3 is 270. So this is 270 degrees if I go around like that. And these are all examples of quadrantal angles. Okay, so we spent a lot of time in degrees, but in fact, the truth is that in calculus, we hardly use degrees at all. But sometimes it can be convenient to think about degrees. Okay, so let's do an example where we sketch some angles. All right, so standard position means that the initial side lies along the positive x-axis. Okay, so that's just our home base right there. Now for 30 degrees, we have to do a little bit of fractions and dividing and so forth. So here's 90 degrees is 1/4 of the way around. If you take 90 and divide by 3, well, 9 divided by 3 is 3, so 30 divided by 3 is 30 degrees. And so this is a 30-degree angle. It's not so clear to me where I'm supposed to put the 30. I'll put it down here. But you might want to put it up here because the angle is 30 degrees, but this 30 up here is indicating this positive angle, the fact that I'm looking at the rotation, which is counterclockwise. Let's look at negative negative 60 degrees. I'm sort of just making one up as I go here because I had another one written down, but I think this one's better. Okay, so look at this as 30. Let's go the opposite way. If I look down here, if I go counterclockwise, when I go counterclockwise, I measure negative. So this could be thought of as negative 90 degrees. If I go clockwise, negative 90 degrees. And then a third of 90, negative 90 is negative 30. And if I double that, I get negative 60. Okay, so here's 30 up here, but if I go clockwise, I'm going to get negative 30, and then I double that, I get negative 60, and then this leads up to 90. So this is the angle here. Sometimes it's hard to do these calculations, but if we work with these numbers enough, then we get used to it. So these angles are called special angles, and we'll see why. So we sort of focus on these all the time. So again, if this is negative 90 degrees, if you add another 30, I get 120. 90 plus 30 makes 120. And that's going to take us right here. All right, I think we're going to stop there.